This is the science show. As we can see, it explores everything about science. This is the science show. In today's piece, acid-base reactions.
Hello and welcome to the show. Today's episode is acid-base reactions. Almost every liquid you see is either acidic or basic. Before we start going a little deeper into the topic, you need to know what some things mean.
Hi people! So I'm here with Irene to talk about the acid-base reaction. So now we're gonna read some definitions of terms that have to do with the acid-base reaction. So an acid is a solution that has an excess of hydrogen ions. A base is a solution that has an excess of hydroxide ions. An aqueous is a solution that is mainly water. And a strong acid is an acid that has very low pH, a 0 to 4 on the pH scale.
Strong base, a base that has a very high pH. Weak base, a base that has a pH close to 7. Neutral, a solution that has a pH of 7. It is neither acidic or basic.
Okay, now that you know some definitions, we can start explaining about acid-base reactions. Acids are compounds that are made of hydrogen ions, which have A+ ions, in another compound. Bases are compounds that are made of hydroxide ions, OH negative, in another compound. Both acids and bases break into the regular ions. In acids, hydrogen ions. In bases, hydroxide ions. And the other compound when they are placed in an aqueous solution.
So if you say it differently, when you put an ionic compound in water, it will break that to two ions. If one of the ions is hydrogen, the solution is acidic. If one of the ions is hydroxide, the solution is basic. In a second, you will see a picture that summarizes what we just said.
This is a picture that simply summarizes the acid-base reaction.
You will now see an experiment we did in the science lab about acid-base reactions.
And this is the base, this is the acid. We're gonna have to mix them together to see what happens. Oh, okay. I'm gonna put like 10 of those things here.
Since this one is quite small.
Yeah, and it's very hard to get. Oh, that's a lot. 9, 10. I'm gonna add water until here is 50 ml. So we're gonna start mixing it. It's really important to mix it.
Wow, this is hard. It's the exothermic reaction when you put the base and water when it becomes
Now we're gonna pour some chloric acid, 100 ml, in this beaker. So I'm gonna pour 100 ml of this thing here. Yeah, we already did. Now we are going to mix the base with water with the chloric acid.
Okay.
When we mix the base with the chloric acid, it kind of like started to not evaporate, but a chemical reaction happened, and then we were only left with a bit of water and salt underneath.
Yeah, because glycerin is
happened here. When you mix a basic solution and an acidic solution, they react with each other and produce salt, and often water and carbon dioxide too. Expert segment. My name is Irene and I am a scientist. Today we will talk to you about pH scale, which we scientists use with acids and bases.
I'm Neta and I'm a scientist.
The pH scale is telling you how much acidic or basic solution is. On the scale of 0 to 14, while acids are in the numbers below 7 and bases are in the numbers above 7. I will remind you that acidic compounds are made of hydrogen ions, and another compound and basic compounds are made of hydroxide and another compound.
So, the pH scale measures the number of hydrogen ions in a solution. If there are a lot of hydrogen ions, which are found in acids, the pH scale is very low and so the solution is acidic. If there is a small number of hydrogen ions, then there are a lot of hydroxide ions which are found in bases, and the pH scale is very high and so the solution is basic.
This is a very important thing to know and remember about acids and bases. Acids contain hydrogen ions and bases contains hydroxide ions.
We will now show a video that summarizes the acid-base reaction.
An acid is a chemical that, when dissolved in water, produces positively charged hydrogen ions. For example, hydrochloric acid, when not dissolved in water, is known as hydrochloride. But when it is dissolved, the hydrogen atoms become positively charged. Other examples of acids are sulfuric acid and acetic acid, although there are many more.
A base is the opposite of an acid. Instead of producing hydrogen ions when in solution, it attracts them. It does this by producing negatively charged hydroxyl groups of oxygen and hydrogen. For example, sodium hydroxide is just a solid, but when it is dissolved in water, it becomes a base. Some other examples of bases are ammonia and magnesium hydroxide, although there are many more. Bases that contain hydroxyl groups are known as alkalis.
There's a way to measure how acidic or basic something is. It's called the pH scale. The pH scale ranges from 0 to 14, with the lower numbers being acids, the middle numbers being neutral, and the higher numbers being basic. pH stands for the potential to attract hydrogen ions. There is a way to measure the pH of a solution by using an indicator. Indicators change color in response to various pH levels. For example, this indicator turns yellow when exposed to an acid. This is because the hydrogen atom attached to the indicator is drawn away to an acid, thus causing the indicator to be negatively charged. Different pH levels give the indicator different charges, thus giving it a wide range of colors.
Now we'll demonstrate a pH test, where we test various chemicals for their pH, using universal indicator paper. We will use hydrochloric acid, vinegar, lemon juice, tap water, pure water, baking soda, borax, ammonia, and sodium hydroxide. Okay, so this is our pH test. We have hydrochloric acid with a pH of around 1. It's a nice pink color there. So that's
This is hydrochloric acid with a pH of 1.
vinegar,
Vinegar with a pH of about.
about 2 or 3.
Lemon juice, or lemon seltzer in this case, with a pH of about 5. Tap water with a pH of about 6, followed by pure water with a pH of about 7, followed by baking soda with a pH of about 8, by borax with a pH of about 10, followed by ammonia with a pH of about 12, and sodium hydroxide with a pH of about 14.
An acid-base reaction is when an acid neutralizes a base, or vice versa. For this one, we will mix hydrochloric acid and baking soda in an acid-base reaction to produce sodium chloride, or table salt, water, and carbon dioxide. Reactions.
And it is wonderful to know about how and why do these things work. Well, that was it for today. Thanks for watching this science show and today's piece, acid-base reaction.